to actually stop this thread, you have to kill this out. Then only so what are you killing is, here you can see here, whenever you start application, your JVM, which is java.w.exe, will be running up, right? So you have to kill this process, right, in order to stop your complete application or your thread here, right? So that is our an infinite loop. Now, so here what I want to do is, so for some iterations I want to create a logic here to kill this, or what I can do is, so once this is done, once my loop is done, let us say I want to sleep for some time here, which is thread dot sleep. Let us say I will give you some 3000 milliseconds to sleep, and then what I'll do, I'll kill my this thread intermediately, which is t1 dot stop. You have stop method anyways, but when I write stop method, right, it will give you a line over there. It says stop is a type thread is deprecated, right? Because this method, you should not use this method. But let me show you, when we use something called stop, right, how it actually stops your thread. Now in this thread, it says I'm in child thread, right, and so many other things will process, right, which is just say sys out of, let's say out of loop, right, and you can just say I'm in child, and just say here still processing, and just say sys out of some print line. So I'll just print some lines here, right, so that we'll see some difference on that. So okay, unreachable call. Why it is unreachable is because this infinite loop. Anyways, we'll create that, and out of loop, let me create it here, which is finally right, out of loop, right. So we'll write this back, because why it is saying unreachable code is, there is an infinite loop and there is no guarantee that it will come out of this infinite loop. So that's why whatever you write in after that, if I say int I is equal to 10, right, it again says unreachable code, yeah, because we don't have guarantee that it will be executed. So that's why you won't be able to do that. Now, as of now, what we are seeing is, we are trying to kill the process from here, right, where I am using direct stop. So when I am killing is, I am trying to complete my execution, waiting for some 3000 milliseconds, and then I am saying t1 dot stop. When I say this, let us see what happens abruptly, right. So after these lines, let me just print something called still processing, some printed lines, and so on. Let me run this, clear this out, and yeah, it is still processing, yeah. So you can see here yeah, so I'll show you here. So every time, when our main thread called, right, main thread, so it started something called I'm parent, I'm child, still processing and all. So when my parent got completed, so this is my 5th instance of my parent, right, and it got completed, right, so it came out. Now you can see printed line I'm in child, still processing, some lines, printed line I'm in child, processing, same 3 lines, printed line and all. Now after 3000 milliseconds, what I did, I abruptly stopped it. See here what happened at end. So every time you see printed line I'm in child, still processing, right. So when you come down, you can see I'm printed line I'm in child, see abruptly it got killed. My still processing is not printed here, right. Why? Because when I called something called stop here, it abruptly stopped, and it didn't even touch the next set of lines. So when I called stop, right, actually that was here, it seems that was here, and I was sleeping for some time, which is 100 milliseconds. Abruptly it killed out here itself, which is it skipped all these statements. So that is why your stop is very dangerous, right. When you are actually creating a separate thread where actually your some processing is done, right, so at that time it will be very tough to actually differentiate between what is happening here, right, because it is actually being killed abruptly, right. So that's why we should not use something called stop. Never use stop. But if you feel that everything is fine, even if my process is being killed at at, at some part which is in between, right, then you can use stop. But again, do remember that this is a deprecated method, so all your deprecated methods will be removed in future releases. There is a possibility that you will not get this same method in a future release. So whenever I'm saying future release, I'm talking about a Java release, right? It may be Java 8 or Java 9, whatever release it is, they will remove these methods. So at that time, again, you have to refine or rewind or go through all your code wherever you have written these deprecated methods. So for that, just don't use this. So let us use some logic here to kill our method. So what logic we can use is, let us say, so in this thread, let me use some boolean, which is a public boolean here, which is boolean can stop something, can stop is equal to false, right? So we are just creating a logic here so that I can kill my thread here, right, which we are talking about. So we just seen something called stop, and we see something called out. So out can be anything, right? It can be a break, return, or manual kill thread. So we'll just see one of these. Anyways, everything can be same as a manual thread killing. Now in my infinite loop, after this complete lines, I'll check whether if my lbln can stop is true, then I want to break this up. So which means when I write break, in the sense I'm coming out of my infinite loop, which is I'm coming out of my process. Now let me just say out of loop here, right, where I just wanted to show you that everything is being processed, and then I'm saying come out, and then it says out of loop. Now you can see that it doesn't give any error here. Why? Because it knows that some or other part of your program will be stopping this infinite loop, and it will come out. Now, so here what we'll do, after 3000 milliseconds, let me just say t1 dot lbln t1 dot t1 dot okay fine, because it is not taking thread, because this variable boolean is a variable of CLS thread, right, and not a variable of thread parent class. So that's why I can't access this. So in order to make it accessible, we can do the first step. What we have seen is CLS thread thread obj is equal to, let me just say CLS thread here, which is obj is equal to new CLS thread, and let me just.
And is it Srinath, is because it is not static?
I'm sorry, no, it is not that. Okay, let me show you that. I was expecting this question actually, not to worry. Yeah. So let me just make it static. So even if I make static, I cannot be able to access from lbln. No, right? lbln. Because my thread is, it is not because of static, because I am trying to access a variable of my child class from a parent variable, which is not possible, if you remember, right? This variable should also be there in my parent, otherwise I cannot access. So what I am doing is, I am directly taking my object of my child, I'll give this child to thread, I'll use the same object to access my variable here. It is not because of my static actually, right? So what I'll do, I'll just say CLS thread obj is equal to new CLS thread. Again I'm creating an object. So here what I'll do, instead of giving this, I'll just give my object to my thread, which is the first step which we have seen, thread, and here I'll give you my object, which is again creating a thread. Now what I'll do, I'll just use this obj here, right, and say dot, you can see lbln here, right, is equal to 2. Fine, Purushottam, now you understood this? Yeah. So now what we are doing is, we have created, so see here you can, so one thing what you have to notice here is, I'm creating an instance of my thread class once, and I'm using this same instance to create a new instance of thread, and also I'm using the same instance to stop it up. When I say lbln can stop, which means automatically in this instance, current stack instance, it will make it true. So at that time when it makes it true, it will be break, right, it will broke. Now let me just create something here. So and just say sys out, just say main thread kill this thread safely, right? Just something in here, and then it will break out of loop and all. So before that, let me just print a line here, and then we stop it here. Now let me run this up. Oops. Clear this and run this. Yeah, so it is still processing. Yeah, can you see here? It says main thread kill this thread safely, right? Because my print line is nothing but a last line here. You can see here, print line is the last line, and then when we did true to this, and again it completed the whole execution and then checked yes this is true, and then it says main thread kill safely and came out of this. You can see it here, right? Main thread kill out of loop, thread 1 got killed. Now it is being killed safely, where there is no skip of any of your statement here. Print line, I'm in child, everything got printed, and after a few lines again it printed something called print line, and then it killed our thread. So this is how this is one logic which I have applied to kill thread, right? You can apply your own logics here, like if you don't want anything to be exposed outside to your class. Let us say you don't have LBN and true, right? You don't have these things, right? And you want to kill.
So, sorry, just a quick question.
Yeah, on.
So the thread got killed after the 5th iteration of the main thread. Is that correct?
No.
If you go back to CLS main.
Yeah, 5th. You're talking about this.
Yes. So now the thread, the child thread was the child thread was killed after the 5th iteration of the main thread. Is that right? Or?
Yeah. I mean, see, after the 5th iteration of main, again I'm making my main thread to sleep for 3000 milliseconds, right? So after this wait only your child thread will be killed. But anyways, you are right that the main thread will complete at least 5 iterations. Then it will stop for 300 milliseconds. Then I'm making it as true. Then it will actually kill your thread. Right?
Okay.
If you want to kill abruptly, right? I can just skip this up. Yeah, you're right. If you want to kill abruptly, once my iterations are done, I also want to kill my child thread. You can do that. Let me just run this up once. See here. So my I'm parent got 1, right? And 2, 3, 4. Right? I didn't start it from, sorry, 1 here, 2 here, and 3, 4, 5. So once 5 is there, I just killed it out. So when I killed it out, my main thread got killed, right? And so finally it printed my child 1 again, which is still processing, and then it got. So immediately after my parent, right, it killed immediately. You can see there are no more lines before, right? So now your whatever you said is right. So after the 5th iteration, I immediately kill my child thread, right?
Okay.
Yeah.
Yep.
If you do any processing in between, right? Let us say if you are doing some int I is equal to some 90 divided by 8. So all this processing will be done, and then your child will be fixed, right? Yeah. So yeah. So what we are seeing is I just wanted to kill this child. So I don't want to use any logic in my main thread, but I want to kill my child thread based on the logic being implemented here itself, right? Now what we'll do, let me just remove everything. And let me just take some int here. Int I is equal to some 0, right? And let me just say I plus plus. So every iteration I want to increment this. And this is again a known logic, right? But this is again a safe logic which we are implementing. Let us say if my I is less than some 20 or less than my 20, right? I is greater than 20, right? Which means when my I goes beyond 20, I want to kill this thread. Yeah, that can happen, right? So let us go back here and just say sys out of I value is overdue something, overdue, plus let me just print the I value here, yeah, and then it got killed. It got killed, okay, right? So we have assigned I is equal. So for each and every iteration, what happens? Your I will be incremented by 1. So at in the process of execution, once your I will definitely go beyond your 20, right? So even if it comes to 20 is not greater than 20, which means it will break your loop, and then you are actually killing your thread safely. And now we are not using any logic in our main thread. So this will run for 5, and let me just give some bigger to this so that you can actually see how many parents are being processed, right? Let's go back, stop this, and just yeah, you can see here print line I value is overdue, right? 21, and just it killed something called safely. Everything got printed, right? Now you may be getting why we are getting 21, because why we are getting 21 here is, why not 20 is because we are incrementing first and then checking, right? Obviously we are incrementing this and then checking, which means obviously it will go to 21 and it will be killed, right? So now here again what we have done is we have killed it safely. Each and every line got executed, and then it is checking, and then it is killing, and you can see each and everything out of loop, and you are finally got printed, which is thread 1 got killed, right? So this is how you actually do the processing, and this processing is again can be done in any number of threads, right? And if you want to keep your thread alive, right? If you want to keep your thread alive, now let us talk about some exceptions here. So internal to this, any exception can happen, as I said, right? Let me just remove all these things, and let me keep one logic, which is killing your flower. Now here let us say some int I is equal to, there is 90, right? And no, sorry, int some a, let me just say, because there is already I. And what I'll do, I'll just do int b is equal to, I'll just say I divided by, sorry, a divided by I, let us say. So now what happens here? So what I'm doing is I'm taking one variable here, a, right? And I'm trying to actually, whenever my I is incremented, right, I am just trying to actually divide it. So what I'll do here, I'll just say sys out of b value, right, and just print something here. So now if you see here, so initially my I value will be 0, right? So when it comes to a loop here, right, what happens here? So it will go beyond your limit, which is infinite. So obviously exception will happen here. So let me just print the exception here. This is error. This is error of, let us say, e dot get message, where I'm just saying exception at thread plus, right? Just some message I gave, and now let me run this up. So exception happened. See here guys, exception happened inside my thread or inside my loop itself. So see how dangerous it is. Let me just, okay, let us say I don't have any processing in my main thread. Let me just comment it out. I'm just calling my thread. I don't want anything to do in my main thread, right? Let me run this. See here, it just started, it said main thread, thread 1 got killed directly. Why? Because for the first iteration itself, when it came into this, right, the complete processing itself got killed, and it directly went to your error where it says exception at thread, and it printed by divided by 0 is not allowed, and then immediately it printed your finally, which is thread 1 got quit, right? So this can happen in any thread actually. Now what to do here? This is very important. If you feel that anything can happen over here, right, then obviously what you have to do is you have to handle exception at that level of point. Now you see here it says yes, my exception can happen here, right, which means I'll handle my try catch here, try and catch here. Now I'll keep all this, whatever you feel that exception can happen there, just keep it there and just say continue. So what happens is it will continue looping again. But here there is one more problem here. So when you say continue, right, again your value I will never be reinitialized, right? It will continuously give you the same thing. Let me just print out that this out of, just say inner exception, right, and just say plus e dot get message, right? So let me run this up first, and let me just say b is outside this is equal to 0 first, and then I'm assigning a b, right? So why I'm assigning outside is I'm printing my b value here, right? So I want to give the scope of b outside my try catch, right? Now yeah, let me run this and see what happens here. Go back, clear this up, run this up. See here, it continuously will give you inner exception. Why? Because so I have to stop this process. Let me just say sys dot err dot printline, so that I want to print it in red. When I run this, you can see, right, inner exception null, continuously it will give you, because we are handling our exception. Again, this is more dangerous than what we did before, right? We didn't handle our exception, anyways the whole thread got killed and it came out. But here your loop will never stop, because you're writing your logic in such a way that you are handling your exception, but actually you are not giving a correct remedy to actually handle your exception. So what should we do here? So the main exception can happen with I here. This can be a main culprit where it can go 0. Now what you have to do before continuing, just say I plus plus, where so let me just stop this process, right? Where what we are doing is we are just giving a remedy that okay, if anything happens, that it can happen with I, right? And we are just incrementing this, because this incrementing should be done anyways, right? So let me run this now. When I run this, once you will get an exception which is divided by 0, and then after that what happened, I got incremented, right? So when I came to 21 and it got killed, now it's safe. So only one instance got killed, but you can see remaining everything got again, remaining everything was fine again. So this is how you actually should handle exception at the point, at the sensitive area where you feel that you will get an exception. Again, if you want to actually handle the completely a try catch, right? Again, it's always better to give the complete for loop under a try catch, right? Here. Now, if you feel that any exception happens in for loop, right, or inside this, so always do try catch and just say continue until it gets breaked, right? So in this way, so where if any exception happens other than this, again it will continue, but there again you have to write your own remedy to what actually to do when it actually gets your exception. Again you can have exception type here like arithmetic exception. If you feel that is the arithmetic exception, right, just say I plus plus, right? If you know that it can happen, so that I can just remove this, right? If I remove these things, again I'm handling only my arithmetic exception over here, where I'm incrementing this, where if any exception happen, it comes to here I plus plus and continues, right? See what happens again here. Let me clear this up and run this up again, right? Yeah, you can see exception happened once, but okay, we are not printing that, right? Let me just print that exception again. Just say sys out or sys err, right? And just say loop exception, right? And let me just print that exception, which is e dot get message, right? Yeah, now let me clear this up and run this again. Yeah, you can see only once exception happened, which is loop exception divided by 0. So we are handling only some particular exception here, which is an arithmetic exception. That's it. If any other exception happens, it will not handle that. Yeah, because if you, let us say if I'm handling something called file not found exception, some other exception. Anyways, you can't handle this because you are not using this. Let us say I'm handling some null pointer exception. Null pointer exception here, but actually what happened, your again I cannot ds here, and I'm not actually handling my arithmetic exception here. Now let us see what happens. Go back here, clear this up and run. Yeah, it directly killed. It is because why? Because we haven't handled the correct type of exception here, which is nothing but an arithmetic exception. So that is why we go for either a complete higher level of exception, which is direct exception, or if you know that what exception can happen, go for that, which is arithmetic exception. Right? If you don't know which type of exception can happen, then don't worry, just go for direct exception class. So this exception class will handle each and every exception for you. Now if I go back and run this, right, you can see one loop exception happened and it will continue your looping. Right? So this is how we actually do create threads, and what are the different things in here, right? And how to start and see, and we have seen something called thread names and different things like infinite loop and how to kill thread and all, right? So let's create some more programs tomorrow, right? We'll meet up tomorrow and we'll see some more programs in here, right? And we'll check out if you have any doubts in this threading, if you have anything in your mind, if you're real time, if you have got any issue with these threads, right? Let's talk about that also, right? So any doubts still here, guys? Hello?
No. Just one quick question. The continue keyword, it goes to the very next code block when you call it, right?
I'm sorry?
The continue keyword,
Mm-hmm.
the keyword continue, once you call that goes to the very next code block afterwards, right?
Yeah.
Great.
It will go to the start of your for loop again. When I say continue, when I say continue, right, continue will actually go back to the start of a loop and it won't go next block.
Okay.
So see, when I say continue anywhere here, right, if I say continue here, right, which means you can see here this is not reachable again, because the continue will never make you loop the later one. Only the continue will go back to the start of your for loop.
Okay.
Yeah, good that you asked that question. Thanks, Ron. Yeah, and break, if you actually define this break token anywhere in between your loop, right, it will come out of that loop only, right? And when you use some token called return, right? So return, what it does is it will actually it will come out of your method itself. Yeah, you understood the difference between break and return? I can also use return here. There is no problem, because as and then I want to kill this thread, right? I can just say return. When I say return, nothing, even not your anything whatever you have defined will run actually. Only the finally will be returned. That's it. Only your finally will be. So let me just run this. So what I'm doing is I'm just killing my thread here, right? I just said safely and all. Let me just print this. Let's print this here. Right, I'm just printing one line, so I cannot print in design time itself. It will give unreachable code itself, right? Because I'm not doing. So if I run this up, right, what it does is it will directly. Anyways, this again, the whole thread will run as it is. There won't be any problem at all. Right? Sorry, let me run this again. Right? See, your thread will run as it is. But only thing what happens is, see, your finally got triggered, which is thread 1 got killed. I have written that in your finally, right? So return will actually completely will come out of your loop itself. I mean, sorry, come out of your method itself. But if you want to only end your loop, which is you have to use something called break, right? Where I'm just giving my scope of break only to come out of my for, right? So that I can actually do something called sys out. I can just say I'm out of loop. Now it will accept. Why? Because there is a chance that once this for loop got breaks, it can come to this statement. Right? So that is what is a break and continue. Fine. Any other doubts? Ron, is that clear?
Yeah, so the return keyword will actually exit the entire method and go to the next method.
Yeah, it will go to the it will go to the method from where you are actually calling this method.
Right. Whereas the continue will just go on to the next iteration of the loop.
Yes, exactly. Yeah.
Okay.
Yeah.
Clear now. Thank you.
Cool. Yeah. Any doubts? Vamsi, Surender, Purushottam. Yeah. So if everything is fine, let's wind up here, right?
This is
Yeah.
Johnny here.
Yeah, Jami. Yeah, please go on.
Yeah. You have a minute.
Sure. Maybe
what's your-
if it is, yeah, I'll talk to you once this is done, right? I'll talk to you
Okay.
so that you know. Yeah.
Yeah.
Okay, guys. Then we'll meet up tomorrow, right? And we'll see much more programming on threading, right?
Will do. Thank you.
Okay then. Thank you. Bye bye.